Florida has always been a place where the unexpected happens, but few could have predicted that in the quiet suburbs of Orlando, a 17-year-old high school student might change the future of electric vehicles. His name is Robert Sansen, and while most teens are focused on homework, sports, and social media, Robert spends his nights and weekends immersed in wires, circuits, magnets, and experiments. He claims to have built something no one else in the world has managed to achieve: the first truly sustainable electric vehicle motor, a machine that, according to him, not only powers a car, but produces more electricity than it consumes. Admirers have already begun calling him the new Tesla, in honor of his idol, Nikola Tesla, the legendary inventor of alternating current and wireless power. The spark of inspiration. Robert's fascination with electricity began early. He recalls reading about Tesla's experiments with alternating current and resonant circuits and being captivated by the idea of limitless clean energy. Unlike most aspiring engineers, he had no formal instruction in advanced physics or electrical engineering. Instead, his education came from the endless resources of the internet. YouTube tutorials, old patent documents, and countless hours of trial and error. What he lacked in professional training, Robert more than made up for with curiosity, persistence, and raw talent. His bedroom gradually transformed into a workshop stacked with salvaged copper wires, disassembled appliances, and spools of 3D printed parts. He wasn't just following instructions, he was asking deeper questions. What if Tesla's unfinished ideas could be adapted for today's clean energy revolution? What if an electric motor could go beyond efficiency and actually sustain itself? Building the Tesla Coil Motor. After years of tinkering, Robert unveiled what he calls the Tesla Coil Motor, or TCM for short. Unlike conventional motors that rely on permanent magnets or rare earth materials, the TCM was built almost entirely from accessible, low-cost components: 3D printed plastic casings, salvaged copper wiring, and a steel rotor carefully balanced by hand. He didn't have access to industrial labs, precision machining, or expensive alloys. Every piece was improvised, printed at home, or salvaged from discarded electronics. In his own words, "If Tesla could build wireless power towers in the early 1900s with what he had, I should at least be able to build a motor in my garage with what's available today." Robert's design is unusual because it blends the principles of a synchronous reluctance motor with elements inspired by Tesla's resonant circuits. At its core, the TCM relies on a special arrangement of coils and magnets that creates a self-reinforcing magnetic field. Instead of consuming all the power it receives, Robert claims the motor resonates in such a way that it produces a surplus of energy, which can then be redirected to auxiliary devices or even stored for later use. Testing the impossible. Grand claims require solid proof, and Robert knew skeptics would demand hard numbers. To validate his prototype, he tested it against two widely used commercial models: a standard permanent magnet motor and a synchronous reluctance motor. Using voltmeters, ammeters, and a laser tachometer, he measured torque, efficiency, and rotational speed. His process was meticulous, repeating the tests several times, recording the results, and ensuring accuracy before making any conclusions. According to his data, the TCM consistently outperformed both comparison motors in torque and efficiency, despite being built from inexpensive, non-specialized parts. The most startling claim came from his energy balance tests. Robert reported that the TCM was generating more electricity than it consumed, allowing him to power additional devices such as LED lights and small fans without draining the motor's main power supply. If true, this would suggest a form of sustained over-unity operation, something mainstream physics has long dismissed as impossible. Recognition on a global stage. Robert wasn't content to keep his breakthrough hidden in his garage. He entered his project, formally titled A Novel Synchronous Reluctance Motor for Electric Vehicles, into the Regeneron International Science and Engineering Fair, ISEF, the world's most prestigious competition for high school researchers. Each year, ICEF brings together nearly 2,000 students from over 80 countries to showcase original work across every scientific discipline. In front of panels of expert judges, Robert described his design, demonstrated his working prototype, and presented his data. Despite his age and lack of formal training, he impressed the judges with his knowledge, creativity, and vision. The result was historic. Robert won the George D. Yankopoulos Innovator Award, the highest honor at ICEF, along with a staggering $775,000 cash prize. The recognition catapulted him from a local tinkerer to a global sensation. Overnight, media outlets rushed to cover his story. Podcasts, online magazines, and YouTube science channels praised his creativity and compared him to Nikola Tesla himself. Admirers marveled at his drive, while critics argued his claims bent the laws of physics. How does it work? According to Robert, the TCM is rooted in Tesla's own ideas about resonant energy systems. Tesla's coil, invented in 1891, was designed to produce high-voltage, high-frequency electricity with minimal current. Robert claims he adapted this principle into a motor system by carefully arranging the coils to create a resonant feedback loop. The TCM doesn't use a commutator, nor does it require a dedicated external power source beyond its initial input. Instead, once running, the feedback system amplifies voltage and frequency, creating what Robert describes as a resonance effect. This resonance boosts torque while simultaneously generating excess energy. Theoretically, the motor could operate from renewable sources like solar or wind, while recycling part of its own output to maintain continuous operation. Critics are quick to point out that mainstream physics maintains energy cannot be created from nothing. The law of conservation of energy is absolute. Robert, however, insists his system doesn't violate any natural law. He argues that resonance allows the motor to capture and reuse energy that traditional designs waste as heat or noise. Whether this explanation holds under peer-reviewed scrutiny remains to be seen. Advantages over conventional motors. Even setting aside the controversy, experts who have examined Robert's prototype recognize several clear advantages. First, the motor stands out for its simplicity of design. Because it does not rely on commutators or rare earth magnets, it is both cheaper to manufacture and easier to maintain than many existing alternatives. In terms of performance, it offers an impressive power-to-weight ratio, producing strong torque despite its small and lightweight frame. The motor also operates with minimal noise and vibration, giving it a smooth and quiet quality that sets it apart from conventional designs. Perhaps most importantly, it avoids the use of rare earth elements, making it far more environmentally friendly while reducing the geopolitical challenges tied to sourcing critical minerals. Taken together, these features suggest that if the motor can be scaled effectively, it could help make electric vehicles more affordable, more sustainable, and potentially more powerful than ever before. Investors step in. With media attention came interest from investors. Several venture capital groups focused on clean energy invited Robert to present his invention in private demonstrations. For many, the motor's potential was undeniable, a simple, scalable, eco-friendly motor that could outperform existing technology. Yet the bold claim of generating more energy than consumed raised immediate skepticism. Investors were impressed by Robert's charisma and vision, but they pressed him with tough questions. Could his data be independently verified? Could the motor be scaled to power a full-sized vehicle? Was it truly sustainable, or would it fail under real-world conditions? For Robert, these meetings are a turning point. Funding could accelerate his research, allow for industrial-grade prototypes, and bring his motor into the automotive market. But skepticism could just as easily stall his progress if backers decide the risks outweigh the rewards. The public reaction. Online, Robert's invention has sparked fiery debates. Supporters hail him as a genius destined to revolutionize transportation, insisting that disruptive innovation often begins with young outsiders. Memes, hashtags, and fan pages celebrate him as the new Tesla, a visionary stepping into the shoes of the inventor who dreamed of free, limitless energy for all. Critics, on the other hand, accuse him of exaggeration, misunderstanding resonance, or even outright pseudoscience. Some physicists caution that claims of net energy gain have been made many times before, only to collapse under scrutiny. Yet others admit that even if his resonance feedback system doesn't literally create excess energy, it might still represent a clever way to recycle wasted energy and dramatically improve efficiency. The road ahead. Robert Sansen remains humble yet unwavering in his vision. He says his mission isn't to silence critics, but to create technology that works, inspires, and pays tribute to the legacy of Nikola Tesla. His dream is to refine the Tesla Coil Motor, scale it for commercial use, and make clean transportation accessible and affordable across the globe. As he puts it, if we want to fight climate change, we can't just settle for incremental improvements. We need leaps. I believe this motor is one of those leaps. Whether his invention truly delivers on its extraordinary promise remains to be seen. Only time, rigorous testing, and independent verification will determine if the Tesla Coil Motor can reshape the electric vehicle industry, or even challenge some of the assumptions written into physics textbooks. Yet even if it falls short, Robert's creativity and determination stand as proof of what young innovators can achieve when driven by curiosity and vision. For now, the world watches with equal measures of hope and skepticism. In a teenager's Orlando garage, the future of electric vehicles might just be taking shape.